Okay, so hello everyone. How are y'all doing today? So first off, let's start with our review. So last time we talked about strings, right? So what's the difference between the equals method and the double equals sign? I think this was on last week's review too, but it's pretty important, so. We're gonna go over it again. Again, feel free to either unmute or just type your answers in the chat. You don't need to like raise your hand or whatever, because we don't have that many people anyways. Okay, does no one remember the answer? If not, that's okay. Oh, yes, exactly. So the equals method compares the content and the double equals sign compares the location. Or like technically like they're just checking if it's like the same object. So, but in order to do that, they look at the location of where this object is stored. Yeah, so what about the next one? String object versus string literal. This was not that important, so it's okay if you don't know it. But basically, string object is like when you create a string like as an object, right? Well, strings are technically already objects, but then like a string literal would just be like the literal like string. Like here, oops, sorry. Like a string literal would just be like, this is a string. Like that's a string literal. A string object would be like, you explicitly like declared it as like a string. Yeah, okay. So now for this one. Do any of you remember how the substring method works? So what would string z look like if string z is equal to x dot substring 5? So remember that with the substring method, we start from the index that is specified in the parentheses. So we're starting at that index and then going all the way till the end of the string. So where does index 5 start? Any guesses? Yep, nice. Z equals all we are now in the hall. Although you can't really see it, but like from like Selena's answer, but like it starts from the space before all. But yes, all we are now in the hall is correct. What about the next one? So for string x, hello, all we are now in the hall, and then do x dot split. So if you guys don't remember, the dot split method essentially like splits a string from like whatever substring you give it. So like here we have x dot split comma, so it's gonna take everything to the left of the comma and everything to the right of the comma. Nope, that is not correct. To the person who just messaged me. So remember, you can see here we have like a string with like the double braces, right? So this is actually an array. So we're going to end up with two strings out of this. A string that consists of everything before the comma and a string that consists of everything after the comma, right? So this is kind of hard to explain, but I think it's pretty easy to understand if you just like see a bunch of examples of it. So in this case, you would end up with an array that looks like hello all, and then another string that says we are now in the hall. Let me type it into the chat. So this is what that would look like. Right, and note the comma here is just for the array, not for like the actual, not like part of a string. Let me, here. Let's demonstrate here. It might be easier to see some more examples of this because the dot split method can be kind of confusing, but it's really useful once you learn how to use it. Oh, I think last time I tried to do it, did the annoying thing though, where it didn't let me print it and instead printed the object location, which is not what I wanted.
Wait, there's a difference between system.out.
Yeah.
And
okay, hold on. Let me just do this. Seriously, why is it being so annoying? Let's just do this. See if that works. Oh, that's really weird. But anyways, that's fine. Let's just do. Oh wait, no, this is Python. This is a for loop. We haven't learned this yet, so don't worry about what this means. I'm just trying to print out the string. Or we're essentially, I'm just gonna print out each individual thing in the string. And hopefully by the end of this class, you will kind of understand what this code does actually, because we're gonna be talking about arrays during class today. Okay, so you can see, let me get rid of this. You can see that this printed out hello all, which is the first string, and then space we are now in the hall, which is the second string, right? Because we're splitting by the comma. So we're taking everything before the comma and then everything after the comma, and we're putting them in an array together. But these are two separate strings. So if we were to change this to splitting by a space, what do you think would happen?
hello, all, like every word would be a separate word.
Like, how many separate strings do you think we're going to get out of this if we split using a space? So we got two strings by splitting using a comma because there's only one comma. So we took everything before the comma and after the comma. But if we have a space, then, yeah, wait, let me count. Yeah, exactly. So you'd end up with 8 different strings by splitting it with the comma. So if you run it like this, you'll see that you'll get a bunch of strings, none of which have spaces. And so you can see you end up with each word in a separate string. So hello all, we are now in the hall, are now each in a different string. Does that make sense? Cool. Okay, so like I said before, what we were just looking at is an array, and it has like these little braces here. So normally if it were a string, we would just have string y, right? But now we have string open bracket, close bracket, y. And so this pair of brackets indicates that this thing is an array. And so a pair of brackets will enclose an array essentially. So we have our array y, which is equal to the result of x dot split. And so what is an array exactly? It's kind of like a list of things, right? We already saw that when we got like the list of strings out of our x dot split method. But what exactly is an array? So an array is a container object that holds a fixed number of values of the same type. The length of an array is established when the array is created, and after creation, its length is fixed. So after you create an array, you can't like make it bigger. So string double bracket y means that y is an array of type string. So that means that this is an array, like a container object, that holds only things of type string. And if you take a look at the main method of any job editor, right? You see you have public class main, and then here you have your main method that gets run, right? Public static void main string args. So you can see this here is actually a string array. And well, we're not going to go into detail about what this whole public static void main string args thing means. But essentially, this is a string array, right, of arguments. So this is just something cool to point out is that arrays are in a lot of places, and it's in the one place that you see all the time. If you're like me and you end up coding a lot, you're going to pretty much memorize public static void main string args. So here's the syntax on how to declare an array object. So the preferred way is to say data type. So in our previous slide, it was string, right? We had string double bracket. So here it can be any data type. So data type double bracket array variable name. So like whatever you're going to name your array, right? You can also do data type without the double brackets and then do array variable name with double brackets at the end, but that's not a preferred way to do it because that's kind of like a weird way to do it. You know, normally you want the type to like be at the beginning and just all be together. So it makes more sense to put the brackets with the data type. And then here you can see, oh, why is this? Should all be on one line. Let me just make this bigger so you can tell it's supposed to be one line. There we go. Just to make it less confusing. So this is how we instantiate or create an array, right? So we have data type, array variable name equals new data type, and then within the brackets, we're going to put the array size. So this is just going to be any number, any integer that is positive, because we can't have a negative amount of space, but any positive array size. And then another way to create an array is to actually give it like a list of items from the beginning. So here we have data type, array variable name, and then here we have a curly braces. And so this is what we use when we want to like give it an array that already has values in it, is we would use curly braces. So here we have curly braces value 0, value 1, all the way up until value whatever. So you can set it to like whatever you want it to be, right? And so then the size of the array would automatically be whatever the size of the list that you just passed into it. So here, let me copy this into the chat so you can just have this list. So this is a way to make a list, right? We have a double my list. And so let me put it over here too. And so if we print out all the contents of this list, we can see, what? Oh. What are you annoyed about? Oh, oops. This is supposed to be my list I. Clearly I cannot type. Okay, so, oops. I changed that too. Oh wait, sorry, I forgot to send the thing to everyone. Thought I did. Okay, there we go. So you can see we printed out this very lovely list here. So these are all the items in our list, right? Or array. And so you can access an array element by referring to the index number. For example, my list 5 would return 34.33. So this is very similar to strings. You start at 0 at the beginning and you go 0, 1, 2, 3, 4, 5. So if you 0 would be 5.6, and then you keep counting until you get to number 5. So in this regard, they're very similar strings. However, arrays, you can update specific elements in the array. So you can update a specific index and assign a new value to the element. So if you did my list 0 is equal to 10.2, and then you printed out my list 0, then you would see that your list values changed. And so you can also see here, now that we've brought up indexing, what I'm doing in this loop, right, is I'm starting with the number 0, and then I'm going to count up until I hit like the length of my list. And so each time this happens, I'm basically getting each index of the list and printing it out. So here we can see at the end, we printed out 10.2. So that's what my list 0 is now equal to. So like I just mentioned before when talking about that for loop, an array has a property length. It is the size of an array, namely how many items are in the array. So if we print out, So if we type in system.out println mylist.length, this should give us the length of our array. So you can see this first number that we got printed out is 10. That's how long this array is. And so when you're trying to get the property of an object, or basically like a variable, like a field that the object has, you don't need parentheses, right? So when we were, this can be also confusing and kind of hard to remember, but when we were working with strings, right, in order to get the length of a string, we had to do like my string.length and then add parentheses at the end, right? This is because length is not an inherent property of the string object. Length is like a method that you have to call in order to get the length out of the string object. But for the case of an array, length is like an actual like property of the object. So it's not a method that you need to call. So because it's not a method, we don't need to use parentheses, and thus we can just do mylist.length. I don't know how much like you probably haven't talked too much about like methods and fields and stuff yet. So don't worry too much about this, but just if one of your length methods isn't working, try adding parentheses or taking away parentheses because you might be using the wrong version essentially. Okay, arrays have a class level static method. Don't worry too much about what that means, but essentially arrays have a method that you can use to sort them, right? Here, I'll paste this into the chat as well. So here you can see it says arrays.sort my list, and then we're going to print out the list. Or here, I'll just do I think it might ask me to import arrays though. Yeah. So if this doesn't work for you, you might have to import java.util at the top, at the beginning of your code. This essentially imports like the array class so that we can actually use it. Package Java does not exist. Might be because this is a weird online thing, so then it like isn't happy with the fact that I'm trying to do this.
For me, the array.sort thing doesn't work.
Find a better one.
For me, the array.sort doesn't work too.
Maybe this one will be better. Well, these two look like the same. Okay. Let's copy this order. I feel like they really look the same though. I feel like this isn't gonna make a difference.
Same thing happened to me for the array.sort.
Okay, this is being annoying. Maybe I need to do this. Aha, okay, there we go. That was the problem. So yeah, you need to import like the little asterisk. So what this does is it imports like everything that's inside java.util. But as you can see, this is our original list, and then we sorted it. And now this is the list that got printed out. So this is clearly not the list that we started with, right? Clearly things were in a different order before. So what you can see is that the sort method essentially by default, it sorted this in ascending order. So from smallest to largest. So we can see that 3.3 is now the first number, and then 4.0 is the second number, et cetera, all the way up to 11,123. So a method must be used with parentheses, like I said earlier. And you can't do mylist.sort, even though mylist is an array. You have to use the class name array. This is kind of like a confusing thing that is a bit beyond the scope of this class, but basically mylist is a type of array, right? And so you are basically importing this array class so that you can use it to do things on arrays. But don't worry too much about that. Point is, it'll only work if you do arrays.sort mylist. You can't do mylist.sort just because of the way Java is set up. So now we're going to talk about multi-dimensional arrays. So a multi-dimensional array is an array that contains one or more arrays. So here, I'll paste this into the chat also. So as you can see, instead of one brace, we now have two braces. Let's see, should I get rid of the previous stuff? You know what, I'll just put it at the end. So now we have two braces. So it's a double brace, a num. And so here we have this array, right? Because we have these curly braces, this set of curly braces. However, inside this array, we also have two other arrays. So we have an int array and another int array inside this larger array. So if we print out, here, let's do that just so we can be less confused when we run it. So what this is doing, we're getting enum1 and then enum2. So what do you think, if we take what is in the first index of enum, what do you think we'll get? Do we get a number or do we get an array of numbers? If we ignore this and we just did like, x is equal to enum1, what would that give us, do you think? What's in the first index of this array? Essentially, these things are like nested, right? So it's like inside this larger array, you have smaller arrays, and then you can even go smaller if you want and make even more smaller arrays inside those small arrays. So that's why you can get multi-dimensional, right? You can also imagine it as like, you can literally draw it out as like a 2D thing. Or it's sometimes easier to look at it like this. If you did this, you can see more clearly how this is a two-dimensional array, right? Because the numbers aren't all just in one row. you kind of end up with rows and columns this way. So what you get when you try and get enum1 is you actually get an int array. And so if you tried to do like system.out.println x, it would probably just give you the location of the object again or something like that. What is wrong here? Oh, let's call it y. So you can see this just like printed out like some garbage looking thing. And that's because that's actually the address of the object, because it doesn't want to print out anything more complicated. But you can see that this address of the object corresponds to this integer array x, which is equal to enum1. And so if you were to print out this array, you would actually see that it would print out this, because this is index 0, and then this is index 1. But yeah, enum1, 2 is then equal to 7, because when you have index 0, then you take the second index of this array. So then you do 0, 1, 2, and that gives you 7. And again, you can stack these even deeper if you want. You can go beyond 2 levels, but that's the basics of how it works. Any questions on this? Cool. So time to talk about other data structures. So there are many ways we can store information other than arrays. Oh, I should just stop hitting present, honestly, because I have so many links and things that I need to paste in the chat. But here's a website that we're going to visit. This is the website of arrays. Let's leave this site. So here we can see the Java documentation for the arrays class. And so you can see there are lots of methods here. If you look for it, you'll find the sort method, which we used earlier. These are in alphabetical order, sort. And you can see there's actually multiple versions of the sort class, and each version of the sort class takes in a different type of array. So you can see we have a byte array, char array, double array, float array, right? So there's many different types of sort objects. And then here's the object array, which is like the general one, right? So we need all these types of sort methods so that when we call sort on any sort of array, it'll give us what we want. But yeah, so that's why there's a lot of repeats on these methods, because they need to be able to take in any kind of array. So they essentially do the same thing, but like with a different like kind of array. And so you need to write a whole new method for that, which is a little bit annoying, but in the long run, it's more stable, because then like you don't have to worry about like things breaking if you use the wrong type. But okay, so we're gonna go to the top and we're gonna go to frames here. This just makes some things easier to see for our purposes, right? So now here's packages. So I talked a little bit about packages earlier, right? When I was trying to import java.util. So we're going to look for the java.util package here. If you scroll down to the end, not the very end though. Got to find it somewhere. Aha, java.util. So you can see after we clicked on this window in the bottom left changed. Here, I'll make it a little bigger. And so this shows us everything that is part of java.util. So when we import java.util, we're importing everything in here. And so since arrays is part of java.util, that's why I had to import java.util in order to use the arrays class. So here, down here, we can find arrays right here. And so that brings us to the page that we were just on, right? And so we can see that there's also a lot of things other than arrays, like array lists, array dequeues, and then even things that are totally different, like calendars, event listeners, you know, there's all sorts of things in here. And so it's pretty commonplace to import the java.util package so that you can have access to all these like structures that other people have created, because it's a pretty basic part of programming. Like it's a good set of tools to use. And it makes your life way easier when you can use stuff that other people have written. Okay, so we're gonna look at the ArrayList class. This is a very useful class. Let me find it. So class ArrayList, right? It's basically like an array, but it's resizable. So the size of the array list can be modified. So that means you can add elements to an array list whenever you want. So if we wanted to use it, you would do import java.util.arraylist, or you could do what I did where you import java.util.star and that imports everything in java.util. But if you didn't want to import everything and you only wanted to import this specific thing, you could just say import java.util.arraylist. And so then you would do ArrayList string myList equals new ArrayList. So you'll note that this ArrayList is an object. It's not like the arrays that we were using before. Right? These arrays, they look like normal primitive types. Like you declare them like this, they're all in lowercase, right? That's what makes it a primitive type. It's all in lowercase. So, but with an array list, you can see that when we try and make an array list, it is in uppercase. So this is an object, and this object is what we imported actually. Where did my screen go? Okay. Let me paste this into the chat also. Okay. So back to ArrayList. So the elements in an array list are actually objects, not primitive types, like I said before. So strings are objects, but things like ints, doubles, chars, those are not objects, those are primitive types. So if we want to use a primitive type, we need a wrapper class, which is like an object that does the same thing as the primitive type. So then we have integer with a capital I, Boolean with a capital B, you know. So here, I'll also copy this because it's tedious, but essentially you can add things to your list, right? And so these methods make it very easy to add and remove things to your array list. This will stop being annoying whenever I paste things. Let me try printing array list, but I think it's also just going to give me an object. Let's get rid of this. Okay, so as you can see, this printed out nothing. Or like more accurately, it didn't print out nothing. It printed out a set of empty braces. This is an empty list. So why did it do that? Because we have mylist.clear method here, clearly. So let's move this. Let's copy this earlier. So let's print out the list right after we make it. And then after we add these things, hold on. Anyways, yeah, to those of you who just joined this class, because I know some of you were not here last week. Hi, my name is Crystal. I'm going to be teaching this class from now on. So Samuel taught the first 4, but he's busy now. So I will be teaching the next, well, I mean, this is the 5th. So, but I was supposed to teach the second half. So last time was the 5th class. This is the 6th class. And then after this, there's 2 more that I will also be teaching. But yes, anyways, as we can see here, when we first create the list and then we print it out, it's empty, right? And then after we add these things, we use the mylist.add method. So we do add apple, banana, orange, and then we print it out. We can see that these things have gotten added to our array. And so we can also, instead of using the indexing that we did before with arrays, like instead of, we can't do mylist like 1. Like this won't work because mylist is an object and not like technically like a primitive array. So this kind of thing won't work. However, we still keep the same concept of indexing consistent, but instead of just doing the brackets indexing, we need to do mylist.get. So if we print out, should have changed this to print out this, but print line mylist.get. And then let's print this out too. And run this again. But essentially you can see these methods are pretty self-explanatory, right? Add something, get something at a certain index. Set will set something at a certain index. So as you can see here, we printed out mylist.get 1, which is banana, since banana is at index 1. And then we set 1 to plum. So then after this, if we print out our list, we can see that our list now says apple, plum, orange instead of apple, banana, orange. So essentially we've replaced the banana with plum. So that's what set does, is it replaces something at a specific index. And then here we have the remove method. So we can remove remove items from our array very easily as well. And so this is pretty hard to do in a regular array, because like if you think about an array as like a set of like boxes, right? Or like you have like a space for each item in your array. So if you have like when you make your array, you like create like 10 boxes for items in your array, right? And so if you try and like get rid of, you can remove items from those boxes, but you can't remove those boxes. So no matter what you do to the array, you will always have 10 boxes. And so this can be kind of inconvenient because this takes up space, right? In your computer, you have a certain amount of space for something. And if you have so many empty boxes, then you're going to run out of space for other things. Because the thing is, you can't put like random other things in your empty boxes because you've already said these boxes are going to be my array. However, what's nice about an array list is that it's very easy to add and remove items. So you can add boxes and also remove boxes automatically when you don't need them anymore. So essentially when you remove one, right, you're removing plum. And so now you have apple and orange. And you can see that like now you just have less items in the array. So now you have less boxes. And so this takes up less space in your computer, which means that you have more space for other things. And so now if we print out mylist.size, we get 2. So mylist.size is essentially the equivalent of like array.length, but it's named size to make it like less confusing. And then you can see mylist.clear clears out the entire array. So we have 0 boxes in our array now, and we just have an empty array list. Does that make sense? This is essentially a more convenient or easier to use data structure than the traditional array. So there are like, if you go to like high school or college, you can take like whole classes that focus a lot on like data structures, because data structures are actually pretty important in computer programming when it comes to what is like the easiest place to store all this information, and also what is the easiest way to, like when you store information somewhere, right, there are going to be different things that you want to do with this. So essentially for different uses, there are different ways that storing data would be better or easier. So you can learn all about those differences in like classes in high school and college. We'll go over some of them now, obviously. And you can see some of this stuff is also in the AP Computer Science test. Like if you look at this list of units, right, they have array, array list, 2D array. So this is pretty important stuff. So now moving away from the arrays, another type of data structure is a dictionary. Hold on. Let me respond to someone in the chat. To answer your question, no, Samuel is not going to be teaching today. I'm teaching the rest of the classes because Samuel is busy now. So Samuel taught the first 4 classes and I will be teaching the next 4. But I'll also paste that in the chat in case. Oh, his internet noped out again. Okay, I need to just like say it like immediately after he sends me a chat message. But yeah, we have a student whose internet keeps noping out. Anyway, so a dictionary is an abstract class that stores key value pairs. So this is not an array, right? So we're not storing like a bunch of things in boxes. We're storing key value pairs. So what this means is that you have a key, let's say some sort of like code word or something, right? Or no, let's not do it, like a name, right? Like soup is like you have a string called soup and that's your key, right? And then this key is going to, you can use this key to get a value out of your dictionary. So like, let's say the value is like the price of soup, right? So you would enter this string and then out of the dictionary, you would get this number, which is the price of soup, or the value that corresponds to the string that you used as the key. So you essentially map a key to a value. This can be a little bit confusing, but let me demonstrate a little bit after I explain hash tables. So I don't think we went too far into what abstract and non-abstract classes are. So don't worry too much about that for now. But essentially, what you need to know is that a hash table is a kind of dictionary. And so wherever we want to use a dictionary, we would use a hash table. So here's our method for creating a hash table. So this is our method to create a hash table. Let me get rid of all this. So this is now our hash table, and we're going to put stuff in this hash table. So you can also see that these methods are also pretty self-explanatory, right? Put is used to put stuff in the table, and get is used to get stuff out of the table. Let me indent all these properly so that you can see them better. Okay, so let's run this and see what happens. So we're putting in 3 and grade, 2 for class, and 1 is important. So essentially the value, grade is your value, and 3 is your key. So now this word grade is associated with the number 3 inside your hash table. And so when you ask for the number 3, it'll return grade. So here you can see system.out.println values in 1. And so this gets h.get 1. So you'll note that it doesn't matter what order you put things into a hash table because they're not indexed on order like an array is, right? So we don't have like 0, 1, 2, 3, 4, 5 like in an array. You can have numbers as your indexes, but it's like this is what's associated with the number 1. It doesn't matter what order you put them in. So doing h.get1 will get you is important. Right, but you could easily do like, this doesn't even have to be a number. This could be like something else. And then if you print collection values, so these are all the values in your dictionary. And so if you remember, the value is the second thing that you put in. So here the collection values are grade, for, class, and is important. So your values are these strings over here. The second thing that you put in, because this is what's associated with the first number. And then enumeration is it's printing out a thing, which is it's printing out an object, which is annoying. Let's see if I can get it to not print out an object. Okay, it still wants to print out an object, but if you can see if what the values print out, you can probably guess what the keys print out, right? It would essentially print out 3, 2, 1, because these are the keys that you're putting in. And then here's the key set, or the set of all keys. Oh wait, no, sorry. This is an enumeration of keys, which is not something that we need to worry about. So let's get rid of that. That's too advanced. This is the key set, so the set of all keys. And so this prints out 3, 2, 1, like we would expect. And like I said earlier, this doesn't have to be an integer and a string. This can be any sort of object that you want. So like you could even do like let's make this a string and a Boolean, let's say. So no numbers at all even. And so we can put in like hello and then make it like true. And then like Java is true. And then like the sky is falling would be false. Something like that. They don't have to be different types either. And so instead of h.get1, you'll notice that number indexing doesn't exist. So h.get1 will return an error because there's no key here that's called 1. So instead of doing h.get1, if we wanted to get a value out of this array, we'd have to do like, we'd have to give it the corresponding key. So like h.get Java would give us true. All right, variable h is already defined. We'll make it h2.
H2 is an element. Let's think.
String cannot be converted to an integer. What? Oh, I need to change these two. Sorry about that. Yes, knowing how to read error messages is very helpful. But as you can see here, so here we have values in 1, or I should change this to Java, but values in Java would be true, right? Because we're getting what's in Java, which is true. And then if we get the values, we get false, true, true. And you can see that this isn't the order that we put things in, right? Like it doesn't matter what order we put it in. And then the set of keys would be the sky is falling, Java, and hello. Does this make sense? And then these kinds of things also have lots of handy methods for us to make clones of them, to clear them, things like that. So quiz time. What is the main difference between an array and array list? There's actually several differences, so you can name any one of them. Anything, come on. There's lots of differences. You got this. No, it's not that an array is bigger. Arrays and array lists are whatever size you want to make them. Yeah, nice. Arrays can't, well, okay, arrays can be changed, but you can't change the size of an array. You can change the size of an array list. That's the main difference. So like you can, like I said, if you have like 10 boxes, right? And each box has something in it. You can take something out of the box and put something new inside that box. So that would be like an array, right? So you can change the items in the array, but you can't change the size of an array. So if you wanted to add another box, you wouldn't be able to do that. With array lists, you can increase or decrease the size of your actual array, as well as being able to, change whatever's in it. So yeah, that's the main difference. Nice job. Next, which of the following declares an array of ints named image? Okay, so it's definitely not the first one, because remember that when we declare an array, we want to have brackets. The brackets are what make it an array. Otherwise, the first one would just be an int. Yeah, nice job. So B is correct. Someone said the correct answer. It's B. So here we have int, brackets, image. So that the brackets, essentially think of like the brackets as being short for arrays, right? So we're calling this int array image. That's how you know it's an array. Any questions on this? Nice, okay. What is the output of the following code fragments? Yep, someone has sent the correct answer again. It is D. So as you can see, this is an example of like being able to change things in an array, right? So you can see we're able to change index 0 of the array to 23. So that'll change this to 23. And so the 2 is no longer there. And then we're changing what's in index 3 to be what's in index 0. So, I mean, not 0, 1. So since 4 is in index 1, index 3 also becomes a 4. So the final array would look like 23, 4, 6, 4. So that if you print out 0 and 3, you would end up with 23 and 4. Does that make sense? Cool. Next one. For which of the following applications is an array not suitable? So this is kind of getting more to what I was talking about with like having to decide what data structure is best for which situation, right? So in which of the following applications would an array not be a good place to store this information? Don't like overthink it too much. Just kind of use common sense about like what you think you can actually put in an array. And it's important to think about these kinds of things because when you're coding, right, you want to kind of like the point of coding is like to have these real life applications that you use. Yep, someone got the right answer. It's B. So the reason why this is not a good thing to put in an array is because an array can only hold the same type of object. So name, social security number, age, and income, those are different types of objects. They're not like the same kind of thing. Whereas the other ones, holding scores on exams, they're all a score, right? So you can put them all in as integers. Or temperature readings, they're all the same thing. They're all a temperature reading. And with the total sales. Yeah, also with your social security number. So you maybe don't want to put that in a random array somewhere. Although, I mean, to be fair, your social security number is probably stored in some very tightly guarded array on someone's computer somewhere. Or more accurately said, a database, which is like a fancier, bigger array that is only used to store information. But yeah. So what kind of data structure do you think could store the name, social security number, age, and income of one individual? Like, let's say you wanted to, yeah. What kind of thing could store all of these things? Actually, or let's take out name. But if you wanted to store social security number, age, and income of one individual in one data structure, what kind of data structure out of all the ones that we've looked at do you think would work? You could put it in an int array, but then how would you know which number is which? Yeah, dictionary was what I was looking for. Like you could put it in an int array, but like these numbers all represent different things, right? With like test scores and like temperature readings, you're putting them all in one array and you know like all of these numbers represent the same kind of thing. But social security number, age, and income, they're all numbers, yeah, but they definitely do not represent the same kind of thing. You would not want to mix up your social security number and your income. Assuming your income has enough digits to pass as your social security number, which it does not necessarily do that for many people. But yes, it'd be nice to put these in a dictionary because then you can say, okay, this is like, you can make your key like social security number or age or income, and then your values could be the integers that correspond to those things. Good job. Okay, next, examine the following code. After the code is executed, what is the capacity of the list and what is its size? So if we remember from, array lists are pretty similar to string buffers, which we covered last time. So like array list is to array as string buffer is to string, right? So it also, essentially an array list also allocates like extra space. And then when you fill up the extra space, it automatically makes more space. It is not B. You have swapped them around. Yeah, it's C. Nice job. So yeah, the capacity of the list is like how much it could possibly hold. So like how many boxes it has, right? And then the size of the list is like how much stuff you've actually put in those boxes. Like how many of those boxes are actually filled with things. So the capacity of the list is 10, since when you created the list, you set the capacity to 10. And then the size is 3 because that's how many things that you put in there. And then Oh, we might be out of time, right? Oh yeah, we are running over. So sorry about that. Let's just skip this question. And then, so very quickly, the data structures we've learned today have one thing in common. They're all a group of items, right? So like everything, dictionary, arrays, they're all like a bunch of stuff that you put together in one place. And so these kinds of data structures have terms called collections and maps. So I'll post this PowerPoint later so you can look at these links later if you want to. But essentially, there are two interfaces and they're the main like root interfaces of Java collection classes. So a lot of these data structures are a type of collection or map. So like an array list is a type of collection and a hash table is a type of map. So these are kind of the two main types of ways you can store information. All this stuff is very advanced and you don't need to know this. This doesn't even have a lot of practical significance. So here are some types of collections, right? Sets, lists, queues, dequeues, maps. We don't have time to go over them right now, but they're basically just different kinds of data structures. And then here's the homework. It's on arrays. And I'll also ask you to create some hash tables. But yeah, I'll post this on Google Classroom later. And if you have any questions about the homework, you can feel free to message me on Google Classroom. But yeah, any questions about any of the stuff on today's class? Okay, cool. If there are no questions, y'all are free to go. Or if anyone wants to stick around so I can explain things, feel free to stick around.